Hi, Assalamualaikum. My name is HILMI bin HASAN. Matrix number is 01 DKA4B. Today I would like to talk about the introduction for Atterberg limit. Atterberg limit are the water contents which define transition between the solid, plastic and liquid states of given soil material. The tests are restricted to cohesive soils with appreciable silt or clay fraction and cannot be conducted readily on either sands or silts with a high sand fraction.
Hi, Assalamualaikum. My name is SYAHIR. My registration number is 01 DKA4B. I will talk about the objective of the Atterberg limit lab experiment. The objective is to determine the liquid and plastic limit of soil samples for the identification and classification of dry soil.
Theory for this experiment is the Atterberg limit can be used to distinguish between silt and clay, and it can distinguish between different types of silt and clay. This distinction in soil are used in picking the soil to build structure on top. Soils when wet retain water and expand volume. The amount of expansion is related to the ability of the soil to take in water and its structural makeup, the type of atom present. These tests are mainly used or clay or silty soils, since these are the soils that expand and shrink due to moisture content. Clays and silt react with the water and thus change size and have varying shear strengths. Thus, these tests are used widely in the preliminary stage of building any structure to ensure that the soil will have the correct amount of shear strength and not too much change in volume as it expands and shrinks with different moisture content. The apparatus for this experiment is balance, moisture bowl, can, glass plate, distilled water, spatula, sieve, and apparatus grande.
Hi, my name is RIFDI 01DKA19F2038. I'm going to continue about the procedure, determination of liquid limit. First, prepare about 250 grams of ground 0425 mm sieve transparent. Next, check drop tray using calibration block size of 10 mm thick. Third is mix the soil with distilled water earlier in the porcelain bowl until smooth with a spatula. Aligns mixture occurs when it looks creamy and uniform color. Separate mixture about 30 grams of mixture and place in sealed containers for plastic limit test. Okay, the fourth is fill the earlier part of the soil mixture to the porcelain bowl until smooth. The soil surface casengrate with a spatula by using the tools for creating grooves. One groove are lined along the center line exists through the center of the bowl. The groove maker to be held upright to the surface of the bowl. And fifth, the spin being spun at a rate of 2 cycles per second, and number of blows to close the groove along the 113 mm was recorded. 6. Take 10 grams of soil in the valley which are close to determine moisture content. Mold is brought out and put in bowl. Porcelain again. Wash and dry the bowl casengrade. Okay, the last one is the excess line in the bowl or porcelain mixed with a small increased distilled water. Repeat step 3 to 6 at least 5 times for a total impact of between 50 and 10. Plot a graph of a straight line for moisture content versus number of blows on semi-log graph paper and determine the liquid limit impact of land 25 times. Okay, the next procedure, determination of plastic limit. First, divide the land which has been separate from the first program to the same 3 example. Make it spherical. Second, soil ball, then roll up with the finger on a glass plate until it forms a cylinder diameter of 3 mm. If the land has not been split, fold and roll the land chassis to be cylinder 3 mm. This is repeat until the land is split on the cylinder diameter of 3 mm. Keep the soil in a covered container for moisture content. Repeat step 2 remaining soil example.
As you can see here, we are using 5 different scans with different number of impacts. The last result is for moisture content percent. The result is 30.1%. For the first can, second can is 30%, third can is 16.67%. Fourth and fifth is the same amount, which is 10%. And this data is for plastic limits. We are used 3 types of cans, and their moisture content is same, which is 1%. So if the moisture content is 1%, for the moisture content percent equals mass of water divided by total weight of solid mass multiplied by 100. The total is 100%. And the plasticity index equals LM minus PL. So it will be 16%.
Assalamualaikum, my name is FIRDAUS, matrix number 01 DKA4B. Now I will present about discussion and conclusion. Discussion. The importance of the liquid limit test is to classify soils. Different soils have varying liquid limits. Also, to find the plasticity index of a soil, you need to know the liquid limit and the plastic limit. The value of limits are used in several ways. There is also a close relationship between the limits and properties of a soil, such as compressibility, permeability, and strength. This is thought to be very useful because as limit determination is relative simple, it is more difficult to determine these of properties. Thus, the Atterberg limits are not only used to identify the soil's classification, but it also for the use or empirical correlation for some other engineering properties. Different types of clays have different specific surface area which control how much wetting is required to move a soil from one phase to another, such as across the liquid limit or the plastic limit. From this activity, it can predict the dominant clay type present in a soil sample. High activity signifies large volume change when wetted and large shrinkage when dried. Soil with activity are very reactive chemically. Normally, the activity of clay is between 0.75 and 1.02, and in this range, clay is called normal. It is assumed that the plasticity index is approximately equal to the clay fraction A equal 1. When A is less than 0.75, it is considered inactive. When it is greater than 1.25, it is considered active. For the conclusion is another method for measuring the liquid limit is the fall cone test. It is based on the measurement of penetration into the soil of a standardized cone of specific mass. The result is of moisture content for liquid limit is 30.1%, meanwhile the plastic limit is 100%.
Okay, next I'm going to continue about safety awareness and discipline in laboratory. Before experiment start, wearing safety equipment. making sure that lecturers or there is a guidance that guides during experiment. Wear metric cards, read safety guidelines, items not linked to laboratory work are not permitted to be carried into the lab. Place the good in a special location that has been designed. Okay, during experiments, don't play during the experiment. Keep wearing safety equipment. Make sure the material for the experiment is good to use. After experiment, clean all the equipment for the experiment. Do not leave any rubbish in the lab. Make sure all the plugs are turned off. And the last one is equipment are put into the right place. That's all. Thank you.